So if I leave it to the default, for example, this is port 25, 26, this is 25, 26, then this is going to be the root switch because of its priority in the MAC, and this is going to be equal cost, same 10 gig capacity. This is going to be the one I pick because of the lesser port number. So now what they said is, okay, here the cost is 4 and the cost is 4 here. Now what I will do is, on a VLAN by VLAN basis, I can tweak the cost. So now they said physically the setup is like this only, no changes there. But now what I do is, for VLAN 10, I will say 25, 26, 25, 26. I will say for VLAN 10, the STP cost on this link is 4. And for VLAN 10 STP, the cost of this is 6. I just changed it. When you do that, for that VLAN 10 traffic, for that VLAN 10 STP instance, this is going to be in the forwarding state. Okay, that's the same thing what you are seeing here also. Wait a minute. Now what I will do for VLAN 20, because for VLAN 20 another STP is running. For VLAN 20, physical setup is still the same. 25, 26, 25, 26. So now what I will do for VLAN 20 traffic, I will make the cost of this 8. And just as an example, for VLAN 20, I will make the cost of this link as 2. Now what happens? For VLAN 20, this port will become my active port. So physically I will have both the links, but my VLAN 10 traffic will be using the top link to travel to send the data, and my VLAN 20 traffic will use the bottom link to transfer the data. Now I can start can't use the word, but kind of load balancing. I'm able to use multiple links available between these switches. So I have 2 links and I have 2 VLANs. Now, because per VLAN I am running STP, I will make VLAN 10 use the top link, VLAN 20 use the bottom link. Okay. What if I have 4 VLANs? Only 2 links are there. Okay, so for VLAN 10 and 30, use this. And VLAN 20 and 40, use this. Okay, that's it, right? Because only 2 links are there, I can use only 2 links. Okay, but how many STP instances are running? 4 instances are running. It's not a benefit for me running 4 instances because there are only 2 links which I can use for load balancing. If I had 4 links, yeah, sure. I can definitely use for VLAN 10 the top link, the first link, the second link, the third link, and the 4th link. I can use. Okay. Anytime a failure occurs, then I will share the link with other VLAN traffic. That's always obvious. But now if I have 4 links, yes, 4 VLANs, I can share one VLAN traffic on one link by tweaking the cost. This is by far the most wanted. Generally, we manipulate with the cost because that's the first in the criteria. But you can also manipulate with the port priority also. You can do that. But generally speaking, cost is where we generally manipulate. You can also go a little beyond. Like I took just 2 switches. If I had 200 switches, for all the VLANs, all STP instances of the VLANs, only one root switch will be there. I can change that behavior. For VLANs, maybe 10 to 50, this will be the root switch. But for VLANs 51 to 100, maybe this will be the root switch. So I can change the bridge priority and I can make this work. That is also possible. Okay, so that I can start now load sharing. Okay, so 4 links, if I have 4 VLANs, then 4 links I can use. If I have 4 VLANs and if I have 4 links, then I can use it as a 1:1 ratio. 1 VLAN, 1 link. What if I have 50, 60, 70, 80? What if I had 100 VLANs? Very easy to have 100 VLANs, right? What if I have 100 VLANs? Obviously, you cannot put 100 ports connecting 100 links connecting to the switches. If I use 100 links to connect to the switches, then where will I have ports for connecting to the systems? So the point where I am going here with is the number of VLANs and the number of links, they're always going to be disproportionate. You will always have more VLANs than the number of links between the 2 switches. So in that case, inevitably, you will have to share a link for multiple VLANs. Inevitable, because as I gave the example before, even in this example, if I have 8 VLANs and 4 links, no, what should I do? 2 VLANs should share these links. So if I have 100 VLANs, then 25 VLANs should use the link. 1 to 25 will use this, 26 to 30, 50 will use this, 51 to 75, 76 to 100. So they have to use it. So using multiple links, I have no problem there. I'm able to use it, but I'm still running 100 VLAN instances. If I have 4 links, I only want to run 4 VLAN instances. I don't want to run 100. If I have 2 links, I only want to run 2 instances. And this is where MSTP is introduced. Working, it is going to work like RSTP. Okay, so you have your alternate port, you have your backup port. Every switch will send the TC and BPDUs on their own. Every switch will originate BPDUs on their own. All of that is like the behavior of RSTP. Okay. However, the number of instances, you will define it. The moment you configure MSTP, what happens is it will create what is called as an MSTP instance 0. It will create this. Sometimes people call this as CSTP. In other vendors, they will call it as CSTP, common STP. Like all the VLANs, they will all be in this one instance. So the only one STP instance is going to run for all the VLANs. Now what I can do is I can create multiple MSTP instances. So it is completely in my control now. 4 links are there. I will create 4 instances. Instance 1, 2, 3, 4. Now within those MSTP instances, I will put the VLANs. Okay, VLANs 1 to 25, they will all use MSTP instance 1. VLANs 26 to 50, they will all use instance 2. So under the instance, I will do a VLAN mapping to the instance. VLAN 3, 51 to 75, VLAN 4, 76 to 100. So the question is, how many instances should I create? And the answer is, depending on how many links you are going to use. Generally, all over the network, you will use a consistent number. So those many instances is what you will generally create. So you do this mapping, and from a configuration perspective, you will also do something called give a revision number to it. It's almost like a ID to that instance. Okay, the word is very bad. It's called revision ID, revision number, but it's basically a ID to that instance you are giving, internal ID, almost like a process ID. So configuration is very simple. You create instances, you map the VLANs to the instance, and you give a revision number to that particular instance. The challenge sometimes is the consistency. You have to make sure all this configuration is exactly the same on all the devices. Otherwise, your MSTP doesn't work correctly. But except for that, configuration is just straightforward. So now when I do this, STP is running in this example 4 times. I don't care. 100 VLANs are there, I don't care. It will run 4 times. So now, instead of manipulating the cost on a VLAN basis, STP, because per VLAN STP is running, I will now manipulate the cost on an MSTP instance basis. So in a MSTP instance 1, this will have a cost of 2. For MSTP instance 2, this will have a cost of 2. For MSTP instance 3, this will have a cost of 2. MSTP instance 4, this will have a cost of 2. So with that, I will use multiple links. Simultaneously, I can use. At the same time, I am only running 4 instances of MSTP. Okay. Now, for example, I mean, this is where, practically you may not need it, but this is where some discussion maybe, some questions may be asked. Okay, this is all running MSTP instances because I have 4 links, or maybe for simplicity 2 links. I'm running 2 MSTP instances. Okay, fine. Then I have another switched environment which is not running MSTP. Okay, so this is a non-MSTP region. MSTP region. So here again, I have 2 links, for example. So if I'm not running MSTP on that side, strong recommendation is go there and run it. But no, if you can't run it, then what you do is what the device will do is, because it detects that the MSTP is not running on the other side, it is going to send BPDUs with MSTP region number 0. So that is the instance 0. So instance 0, which is common STP, it is used in 2 places. 1, when I am talking to a non-MSTP region, I will use MSTP instance 0. 2, within the MSTP region itself, what if I have this mapping like 51 to 75, 76 to 100, and then what if I have VLANs 101 to 150 also in that region? I did not put them in any separate instance. So anything that you did not put in a separate instance, they will all fall under MSTP instance 0. So within the MSTP region, the VLANs that are not mapped to any instance, they will be mapped to MSTP 0. And if I want to communicate to a non-MSTP region, then I will use MSTP 0 instance by putting all the VLANs in that one common STP instance. From a configuration functional point of view, what we do is, if I have a connection like this to this switched network again, this is MSTP, this is non-MSTP region. If you want to change any cost, if you want to change any port priorities, you just do it on the instance 0, because that is how they both talk to each other. Okay. So that's it. That's about it. You reduce the number of STP instances based on the number of links you have, and you can start tweaking those instances to use all the links parallelly. Right?
But in MSTP 0, there will be no load balancing.
Yes. Okay, see, if you look at any instance, why MSTP 0? If you look at any one single instance, load balancing is never happening. Think about it. In MSTP1, I am using only one link.
Mm-hmm.
I don't do load balance. I cannot do load balance. MSTP3, I am using only this link, the third link.
Okay.
Never I am doing load balancing. The trick is I am making certain VLANs, certain instance, use that top link. I am making another set of VLANs, another set of instances, use the second link. Because there are multiple STP instances running, I'm able to tweak and make them use it. Okay, that's why I said it's not load balance. I refuse to use the word load balance, but it's kind of load balance, right? I'm able to parallelly use the links. I think that's a better way of telling it.
Okay, because in PVST we are just allowing multiple VLANs, multiple links. Load balancing. So that's what I thought in CST, MSTP0. There.
Okay. Again, it's a perspective, right? Yeah. Okay. See, if you think in that direction, then instance 1 is I don't want to use the word load balancing, load sharing. Okay. All these 25 VLANs are sharing
Right.
one link. Yeah. So if you think in that direction, then instance 0 is also shared by all the VLANs. Think about it, right?
Right.
Yes? Yeah. All right. Okay. So I think that's it. So now we ask people to go, okay, there are like 25 switches, 50 switches in our environment. Please go and configure VLANs 10, 20, 30, 10 for sales, 20 for HR, and 30 for IT. Configure it like that. Like this, like 25 VLANs, 30 VLANs, whatever. We ask them to go and configure it on all the 50 switches. So, couple of problems. Okay. Couple of problems. I mean, don't shoot me after explaining all this. After explaining all this, I will give you a last line. So when I give that last line, don't shoot me. So let me explain. So yeah, there are 100 switches, and so there are like 100 VLANs. Go and configure all the 100 VLANs in all these 100 switches. That's a lot of overhead. So they said, okay, we will use a protocol called VTP. Now, when I say VTP, I'm talking version 2 here. We will explain version 3, subtle differences. We will talk about that. But version 2 is what we are using. Version 1 is completely outdated. So we have this VTP. Okay, so what is the job of VTP? VLAN trunking protocol. So what's the job? It is simply to exchange the VLAN database. That's all, nothing else. It is simply exchanging the VLAN database to other switches. How do you enable or disable this? There is no way to disable VTP. You can't disable VTP. Now I'm talking version 2. Okay, so you cannot disable VTP. Okay, fine. Then how do you enable it? So it's already enabled or what? No. That is also wrong. When a port is enabled with trunk, when you enable the ports with trunk, it can happen dynamically or manually. Manually is always preferred for security reasons, we said. So if you enable trunk, automatically the VTP is enabled on those ports. So there's no special commands that I give to activate enable VTP. You simply enable trunk and VTP will run on that trunk port. Again, what is the purpose? Simple. VLAN database exchange. That's all. That is all it will do. So when it comes to VTP, the purpose is VLAN exchange. We have different VTP modes. We have different VTP modes. What we have by default is called VTP server. And then we have VTP client, and then we have VTP transparent. Again, whatever be this mode I am going to discuss, what is the job of VTP? Again, I'm repeating myself here. It is simple. Simply exchange the VLAN database. That's all. Okay, so I can exchange the VLAN database to anybody. Like if I connect a rogue switch here. Okay, this is not officially in my setup, but I connected a rogue switch and I managed to get a trunk. If I manage to get a trunk, then all the VLAN information will come from this switch one to this other rogue switch. So anybody can exchange? Is it? And the answer to that is, if you want to exchange, and if the exchange has to be updated, like if I have to take those information, we need to configure the VTP domain and we need to configure the VTP password. VTP domain is kind of mandatory. VTP password is optional. Now, don't get me wrong. It does not mean, okay, I can configure password here. I don't need a password here. No. That's not what I'm saying. Implementing a VTP password is optional. But if you decide to implement VTP password, then you have to implement it on all the switches. And in real world, you will implement VTP password. So it's almost like a shared key. So only if the VTP domain and only if the VTP password is a match on all the switches, only then the updates will be accepted and only then the updates will be accepted from the other side. Okay. Now, here is something, some people will say, in version 2, VTP domain is automatically taken from the neighbor. So what it means in English is, if you configure the VTP domain on this switch, and this switch will automatically get that VTP domain name and it will take it. Okay, so that happens with VTP version 2. But let us not play games. In real world, you will configure a VTP domain on all the switches. Okay, and you will also configure VTP password on all the switches for security. Right? If the VTP domain and password are not matching, then the updates will not be sent or received. So they are not going to accept the updates. So as a rule of thumb, the domain name and the password should be the same. Okay. So with that said, now what is this modes? In the VTP server mode, what we can do is we can modify the VLAN database, modify the local VLAN database, and update ourselves with the VLAN database. Received. So if this is a server, if VTP server is configured here, this is also a VTP server configured. I can make changes, which means I can add, delete, or edit VLANs. I can add a VLAN 10 sales and I can add a VLAN 20 HR. And here I can go and I can add a VLAN 30 ID. No problem. I can do that. And when I do that, they will exchange the VLAN databases to each other. So not only that I will be able to modify the local database, but I will also be able to get the update from the other VTP servers. Okay. In the VTP client mode, only update is what I can do. Okay. And propagate the updates. I will also propagate the updates. So if I configure this as, instead of a server, if I configure this as a client, I cannot make any additions, deletions, or editing of the VLANs. all the VLANs I will have to create in the server. In this client mode, I cannot create any VLANs. I have to create them in the server, and the client will simply update the VLANs. Now, if there is another client here, I will propagate them, and this client will also update the VLANs. Okay. Now, here is a bad setting, bad default setting. The default setting for a VTP is a server, meaning if I have 200 switches, in all the 200 switches, I can go and make changes. I can modify, I can delete, edit, I can do all of that stuff in all the 200. See, the idea of VTP is basically to exchange the VLAN databases, right? I told this 5-10 times. So the idea is I will configure the VLANs in one place, and in all other places, they should only be updating so that there is configuration consistency. Management wise, I don't have to configure in all the switches, and consistency wise, I will have a common consistency. So, in my opinion, if you had client as the default, right? If you have client mode as the default, it would be easy. 100 switches are there. I will go to one switch and say server, VTP mode server. So on that switch, I will start creating the VLANs and all. But now with the default server, what I should do? I will go to the remaining 99 switches and I will have to say client, client, client. Okay. So that in all other switches, misconfiguration cannot happen because you can't edit or delete any VLAN database there locally. So now that would be better. Okay. But then this is what the default is. Okay. Right. Now, before I get into the transparent, I have to tell you this. Okay. You said if there are two servers, they can update the databases. Whose database is updated? Is it going to merge? Is it going to overwrite? And which one will be taken? Which of the databases will be taken? And the answer to that is what we call the revision number. Okay. A very horrible, pathetic way of breaking the tie. It's called revision number. Okay. This is how the revision number works. It will start with 1. And anytime you make any changes to the VLAN database, your revision number will be incremented by 1. So you add a VLAN 10, revision number is 1. You add a VLAN 20, revision number is 2. You delete a VLAN 20, revision number is 3. You add a VLAN 30, revision number is 4. You modified the name of the VLAN 30, revision number is 5. You get the point. Anytime you make any changes, add, delete or edit, modify, any of the changes you make on this VLAN database, your revision number will be changing. So you are doing these changes on switch 1. Same thing, they are doing it on switch 2 side because both are server, right? When they exchange the VLAN databases, the one with a higher revision number is going to be taken. Now, I said this is horrible and pathetic way of breaking the tie. Why did I say that? Because the revision number is higher does not mean that is the right information. Okay? Maybe I'm cranky and I'm making all these mistakes. And finally, I end up saying 10 is for IT, 30 is for sales, and 40 is for HR. But in the process, I have done so many alterations, deleted, recreated, and renamed, and again all that. End of the day, this is wrong from what I am supposed to configure. Because my revision number is higher, taking that does not make sense. It just doesn't make sense. But hey, that is how it will work. Okay, that is exactly how it will work. So in order to avoid all this fuss, okay, what we do if we decide to use VTP, 100 switches are there. We go to these 99 switches, we configure them as client. One switch, we will keep it as a server. Any changes I make, I will change it on that server. And all these are going to automatically get the update. I am making an assumption that all of them are configured with the same domain name and same password. Only then they will accept those updates. And that's it. No other alterations. Don't play around. This is what you are supposed to do if you decide to use VTP. Okay. What is this then? Transparent. What is this mode? In transparent mode, what happens is we can modify the local VLAN database. We can modify it. That means we can create, we can add, we can delete, we can edit. We can do all of that to the local database, but not update. Neither accept nor send. Neither I will accept the updates coming from others, nor I will send my updates to others. I don't do any of that. But they will be propagated. So I don't mind bypassing it. That's why it's called transparent. I can bypass them, no problem. So what I mean by that is this. For example, you have this server. So you have these 3 VLANs here, and then you have this client. I want the same 3 VLANs to be on this client also, on switch 3. But there is a small security requirement for me, let us say. The security requirement is, in this, I also have VLAN 10, 20, 30. I have them. I want them. But along with that, there is like VLAN 45 and 55. I mean, these are for security. Maybe they are doing some R&D. There is some special application, whatever be the reason. Some of those ports are in VLAN 45 and 55. I don't want these VLAN database information to be exchanged to any of my switched environment. I don't want it to be exchanged. If I don't want to be exchanged, then what I do is I will create this as, instead of a client, I will create this as transparent mode. By creating this as a transparent mode, there is a side effect. I have to create all these VLANs again, because if the VLANs are coming from this switch 1, which is a server, I won't take them. I won't accept those updates. So here individually, I have to create these 3 VLANs again. But along with that, I will also create my personal VLANs. Okay. So I will individually have to create all the VLANs because I can make changes to my local database. I will do that. But the VLANs coming from there, maybe there is another VLAN 50 added. No, I won't take that. However, I will bypass, I said, meaning I don't mind sending these updates, the VTP updates on the other side of the trunk. So this client can take them and they will populate. Okay, VLAN 20, 30, 50, they will populate. So I can transparently send them, but I don't take them and accept them, nor I will send my local updates to anybody. This is completely localized. In effect, by configuring VTP transparent, I am saying, no, I am not advertising it to anybody. Okay. Now, the last statement. Don't shoot me for this. Which mode do you think we will use in production environment? Answers, please. Guys, make a guess.
Yeah, mostly it's transparent mode.
Transparent. That's right.
Right. Okay, so effectively, I am saying I am not interested in VTP. That is what you are effectively saying. Okay. So, reality, people use transparent. So, really, I'm going to discuss the differences between VTP version 2 and version 3 now. But really, in real time, in real world, nah. We want to use transparent. Okay, not a good thing. So that's why I said, don't shoot me. See, I was trying to give you the advantage of VTP, right? I was trying to say, okay, you can have a centralized management, 100 switches. You make one switch as the server and you can push the configuration to all the others. Easy management, I said. And misconfiguration can be avoided, I said. But in real world, what if you make a mistake in the server? Just a typo. Okay, I created VLANs 1200, blah, 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 and then I said I forgot to remove a VLAN, no VLAN 50, blah, blah, blah. And then I wanted to create VLAN 51. I said up arrow and then 52, I said. Imagine that. And 52 is used for my management. Gone. Like the entire switched network loses VLAN 52. I'm supposed to create VLAN 51. I pressed an up arrow, which I deleted VLAN 50. And that becomes a mess. People have experienced this in the beginning of VTP itself, early days of VTP. And they said, come on, 100 switches, 100 VLANs. I can create it in one command, okay? Copy paste, I will do that. I have my Excel sheet, I have a copy paste, I know how to copy paste. I will do that. 100 I will do. I will not take the risk of messing up the centralized database. Adding an unnecessary VLAN, no big deal. But if I delete a VLAN, which is in the production, disaster. Okay. So they said, no. Thank you very much for your centralized mechanism. Thank you, VTP. We are not using you. That is what they have told in effect. Okay. So, do you want to still continue discussing VTP? I don't mind. We will talk about VTP version 3 now. But reality is that. So they understood it. Like Cisco understood, people understood this. And then this developed this VTP version 3. Now with VTP version 3, they made a couple of 3 advantages, I would say. The number one they said is, they made the concept of primary server and a secondary server. So you said there is probably, somebody can make mistakes, they said, right? So you can configure a primary server and secondary server. When you configure a primary secondary server, as long as the primary is there, you cannot go into the secondary server and make changes. As a matter of fact, when you try to make changes here, it prompts us saying primary is up. So what it is trying to say is go to the primary and do the config. This is one enhancement they made, but people are not convinced. Again, the whole point is, it's not about primary, secondary, right? It's about what if I go to this primary and make a mistake? That's the problem people have. That's the concern people have. But then they provided this. Okay, something is better than nothing. So this is one enhancement they made. The second enhancement they made is, with VTP, the private VLANs and extended VLANs can be exchanged. In VTP version 2, you can only exchange VLANs from 1 to 1006, which is the standard VLANs. Only VLANs within this range you are able to exchange. You are not able to exchange beyond this up to 4096, and you are not able to exchange the private VLAN details. Now with version 3, you can update the private VLANs and the extended VLAN information as well. Again, people are not convinced with this. Now you mean to say I can make mistake in the private VLANs also? Okay, I know I'm bad mouthing this VTP, but no, this is what is happening in production. So that's why I'm telling you this. So this is another option which you have, like another enhancement they made to VTP. And third enhancement they made is now you can enable or disable VTP at port level. You can do that. Previously, if you enable trunk, that's it. VTP is running on that. Okay, but now you have the option of the mode off. Basically, you have an option of disabling VTP on your devices. You can do that. Instead of configuring them as transparent, you can simply disable VTP altogether. Yeah, I think I will like this one. And another thing which may be useful for us is now VTP can be used to exchange MSTP configuration. Oh, VTP was traditionally used to exchange VLAN databases, right? But now I can use VTP version 3 to exchange the MSTP configuration. So when we configure MSTP, I think I told you that we have to create these these instances, map the VLANs to the instance and create the revision numbers, revision IDs. Instead of doing that on all the switches, I can simply do it on one switch, ask VTP. Default it won't exchange, but I can ask VTP to exchange the MSTP configuration. I can ask it to do it. Okay, maybe I will use it. I don't know. And that too if I have MSTP running in my setup. So maybe I will use it. But again, if I go with the same bias, same partiality, again the same problem, right? If I make one mistake in the centralized database of MSTP, that will affect the entire switched environment. So I don't know. Tomorrow, if somebody is asking you the differences between VTP version 2 and version 3, you can give the answer. Okay. Will you use it in the production network? I don't know. Most of the time, you don't want to use it. Okay. So that's it. Okay. So, yeah.
So, Kalyan,
Yeah.
so in those environments where we have 100, 500 more switches, so definitely in case of Cisco, we are using VTP concept to simplify the configuration of VLAN. But what about other vendors like Juniper, HP, what they are using?
What I am saying is, even in Cisco, don't use it. People are not using it. Why didn't you go with the assumption that people will use it?
Yeah, not assumption, because mostly we used to configure it for just means to say that we don't want to just configuring separately on each switches VLAN configuration, so we are using it from the server switch. So here we are using the VTP concept in Cisco. But similarly, there will be any protocol in other vendors.
I mean, again, there might be. I'm not 100% aware of what exactly these people are using. But I hope I have conveyed the point that production network people are not willing to use VTP, even though Cisco supports it.
Okay, you mean to say that?
You're telling it is Cisco proprietary and therefore management wise it will be easy and therefore people will use VTP. But the answer is no. 9 out of 10, they won't use VTP server and client. They will simply configure transparent. So did I mean people will go to these 100 switches and configure the VLANs manually? Yes. Yes.
Okay.
But then your actual question was, is there any equivalent? Is there any equivalent protocol like VTP in other vendors? I'm not 100% sure. Maybe I'll quickly Google for it if you don't mind.
Okay.
Even if it is there, we don't want to use it in the first place, right? Okay. Yeah.
I was assuming that might be like Cisco, other vendor will be using any such protocols to propagate the VLAN information on all the switches.
In Juniper, they have this thing called GVRP. Okay, it's a little weird name. They have this thing called GVRP. It's a generic attribute registration protocol.
Okay.
Yeah. So there is this thing again. By the look of the name, I am assuming it is not just for VLAN database updates. It can be used for multiple such things. Like for example, VTP version 3 is exchanging VLAN database, also exchanging the MSTP exchange, right? So similarly, I'm assuming again, I'm making an assumption here that it is exchanging not just the VLAN database.
Okay, then no need to go for that because as you are suggesting that we are not going to use VTP concept.
Exactly the point, right? Yes. Even though it is there, we are not willing to use it.
Yes. Okay.
All right. And looks like it is also being used for some dynamic VLAN mapping. Again, all of that for VLANs database exchange. So yeah. So yeah, that's about it. And I think that's it. So now where will we focus? I don't know. Maybe, yeah. We will focus on first hop redundancy protocols. First hop redundancy protocols. Okay, we have all this crazy big network with a lot of redundancy. Switched environment is there. STP is taking care of redundancy and the loop avoidance. I am using PVSTP or MSTP and able to use multiple links simultaneously, which is a good thing. End of the day, all of your switched environment, if it just relies on this one link to reach the gateway, that's a problem, right? You may have, and most likely you will have, redundancy in the WAN going to multiple ISPs, etc., etc. A lot of redundancy you are providing. But again, end of the day, if you are just relying on this one single link, and if that one link goes down, gone. So how do you solve the problem? So the way you solve the problem is you are going to have a redundant gateway. You are going to have one second, there is a question on VTP pruning. Guys, where is this WebEx window? Guys, are you able to see this screen here?
Yes.
And where is the WebEx window here? It should be down below, right? I am not seeing it. Funny. Yes, Akhil is asking about VTP pruning. I don't want to use VTP, and now you're asking me to do VTP pruning. Okay. But VTP pruning is kind of interesting point to understand, and sometimes it is one of those things which will stop communication from happening. Okay, so that's a point which I think is worth talking about. Definitely worth talking, VTP pruning. So here is the deal, guys. So before going to the first top redundancy, let's talk a bit about this VTP pruning. Maybe I'll use this space. Okay, so now here is the deal, right? You're running these two ports in a trunk, right? You're running these two ports in a trunk. Now, as soon as you run a trunk, what it means, it will allow all the VLANs, right? By default, it will allow all the VLANs, but the right definition I gave, it is going to allow multiple VLANs, I said. Okay, so if you want to tweak, you can tweak it. You can tweak by saying, okay, I will only allow VLANs 10, 11, 12 on this trunk, and I will allow 13, 14, 15 on this, or maybe I will allow 10, 11, 12 on this itself, 10, 11, 12. So I'm going to allow only certain VLANs I can control. Who asked the question? Okay, yeah, yes. Is this VLAN pruning, Akhil? I'm only allowing 3 VLANs. So is this VLAN pruning? Just asking, curious. By default, all the VLANs are allowed, but I said, no, not all VLANs, only VLAN 10, 11, and 12 should be allowed. Is this VLAN pruning? Guys, able to hear me?
Yes,
Yes, Kalyan.
Okay,
Yes,
okay.
Yes.
Yeah, Akhil. So just want to know your take on that. What do you think? And anybody, not just Akhil, anybody can answer.
Yes, Kalyan, we can say that.
So by allowing only a set of VLANs, we did VLAN pruning, yes?
Yeah, I mean, purpose of pruning is that where VLAN is not configured, we can prune.
Yeah, Akhil? You said okay, so that is VLAN pruning, right? Okay. Wrong. That is not VLAN pruning. Okay, so this is the thing. Okay, this is what is important to understand from VLAN pruning, VTP perspective, VLAN pruning perspective. Okay, yes. What do you mean by pruning? You're not sending that particular VLAN traffic on that particular link. That is what English meaning of pruning is. So if you take that English meaning, yeah, I am pruning. I'm not allowing other VLANs. I'm simply allowing only a group of VLANs. But that is not the key point. This is something from an administrative perspective, you did it. Okay. Now the real use of this and where you need it in real world for troubleshooting especially is this. Once you allow these VLANs, what happens? Remember we said STP is running on a per VLAN basis, right? We said STP is running on a per VLAN basis, which means for every VLAN, in this example 10, 11 and 12, BPDUs will be sent. In the BPDU, you have the bridge ID. In the bridge ID, you have the VLAN number, right? In the priority, you have it. We saw that. So what happens is this. Once you enabled these VLANs on these ports, the switches on the trunk, they will keep monitoring the BPDUs. So BPDU for VLAN 10, BPDU for VLAN 11, BPDUs for VLAN 12. They will keep monitoring these BPDUs. This is what happened. On this switch, I did not configure VLAN 12. I did not configure. Okay, so if I did not configure VLAN 12 on this side, one second, I've just changed the direction, that's it. I did not configure VLAN 12 on this side, okay. No VLAN 12 on this side. So when I did not configure VLAN 12 on this side, but I allowed all the VLANs, okay. So what happens now, this switch, because it is only configured with VLAN 10 and 11, this switch will send BPDUs for VLAN 10. It will send BPDUs for VLAN 11. It won't send BPDUs for VLAN 12 because VLAN 12 is not configured. According to the trunk configuration, it is allowed. But that VLAN 10 is not in my VLAN database. I did not configure it. So now what happens? The BPDUs for only 10 and 11 are going in this direction. But whereas the BPDUs 10, 11, 12 are going in this direction. Now what this switch will do is, this will keep monitoring them. Okay, I am getting BPDUs only for 10 and 11. I am not getting BPDUs for 12. So that means I will prune VLAN 12. That is what it does. We are not even aware of that. The show command will show us, but we, from a configuration perspective, we don't even know that. If I look at my show run config, I will see 10, 11, 12 allowed. Here also 10, 11, 12 allowed. Now what happens is this. If any traffic is coming from VLAN 12, I won't even send it on this port. It's a trunk port, but still I won't send it because I have pruned it. How did I know that I should prune it? Because I'm not getting any BPDUs for that VLAN 12, meaning VLAN 12 is not on this switch. That's the assumption I will make. And this will create problems in communication. So maybe there is another switch 2, there's another switch 3. Here there are VLAN 12. Here there are VLAN 12. Okay. But then I cannot send because VLAN pruning is done here because this switch is not configured with VLAN 12. It won't send BPDUs with VLAN 12. And so pruning is done. So this will lead to communication problems. 100 times you will give the show command. It is trunk, trunk, trunk. Allowed VLANs is 10, 11, 12, 10, 11, 12. But the data will not go because this is. I mean, solution is very simple. Go and configure VLAN 12 here, over. Problem solved. But the thing is, that is what pruning really means. What we do here by giving the allowed VLAN list is, yeah, that is also pruning in English. But this is our real concern. What I was discussing with you here is the real problem. So keep an eye on that. When you see the VLANs allowed list and the VTP VLANs pruned, they must be the same. Okay, I mean, VLANs pruned should not be there, first of all, and the VLANs allowed should be the same on both the sides. If anything is pruned, you will see that in the pruned list, and that means the other side is not configured with active VLANs, or the VLAN itself is not configured. So you have to verify that on the other side. So that is something which we should know from pruning perspective. Okay. Yes. Akhil, now I think you got it, right? So yes, of course, by allowing certain VLANs, you are doing pruning, but that's not the real problem. The real problem is misconfiguration will will dynamically prune certain VLANs, and that will create communication issues. So keep an eye on that. Okay. Oh, right. So then,
Kalyan, is it enabled globally?
yes, you don't even enable it. It's done. Okay. This, whatever I explained dynamically happening, it's already going to happen. You cannot avoid that. Okay. What you can do from a port by port basis is allowed list. This you can do port by port basis. What happens in this dynamic pruning? You cannot avoid it. The only way you can solve this problem is configure 12 here properly. That's it. Yeah, thanks. Okay. No problem. Okay. All right. So now I don't want to start first stop redundancy. Okay, we'll take a break. 2:30 we'll come back and then we will discuss the first stop redundancy protocols. HSRP, VRRP, GLBP. Okay. With that, I don't know. Should I start the data center or maybe we will leave?
Batch 2020.
We are able to talk to branch 6 R6 routers. No problem.
Yeah,
Okay.
means B2
Forget
is
it.
communicating with
Where is the
B1
issue?
bidirectionally.
Yeah.
Issue is between these customer A3
And
and A2.
A2. Okay, fine. So
A3, A2 and A1.
Yeah, you are saying the routes are present in R5, right?
Yeah, means
Routes are coming to
previously it
R5.
was
Still
there
you
in
are
the
not
routing
able to
table, but
communicate.
just let me check one thing.
Yeah.
See, right now I'm not, means this loopback IP address is not there in the routing table on this, but it is on router 8. See, this.
So it is not going to the R5, but however it is going to R8.
R8, but and I'm also not able to ping this 111. My source actually, which is see.
Take me to. Okay, first I will solve this problem. Okay, because you said, I mean, we can see that the route is there, but still not ping is not happening. First,
Yes.
take me to R3.
R3, okay.
R3.
I'm
Show IP route OSPF.
No, it is between this router 3 and router 8. RIP is configured actually.
Can you please give show IP route OSPF?
Okay, yeah, sure.
Okay. So the 2.2.2.0, 1.1.1.0, those are, I'm assuming those are the routes of R1 and R2.
Yeah, yes, R1.
You don't have the route to R4. Where is the route to R4? Internally, you don't have communication to R4.
See, this is the loopback.
So that is the R4?
Yes, R4. This IP address belongs to router 4.
Yes. Now, if that is the loopback, the address you are seeing it is a /32. I told you yesterday also, that loopback you have to go and say IP OSPF network type point to point. Go to R4 first.
Okay.
Go to loopback, whichever that is, 172.16, blah, blah, blah. Loopback 1. Make that as IP OSP of network type point to point.
Point to point, correct?
Yes. Yes.
That's only enter.
Yes. Yeah, that's it.
Okay.
Once you do that, check on R3 now. See the effect of it. On R3, you were getting /32. Now you should get the exact network. Give it a little more time.
Yeah, now we are getting this entry. This one.
You're still getting a /32 there.
Yes.
That is not. And another question here. Did you configure the loopback as a /32 itself?
Yes.
Okay. So if it is a /32, you will not have data plane communication.
Oh, is it?
Yeah.
On
So-
route control, this is means /32. Yeah, slash I have configured slash.
/32. Okay.
Mhm.
So change that to something other than /32. It could be /30 or whatever. Okay.
Okay, I will.
That's the one thing.
I will.
The second thing is,
Yes, yes.
yeah, please. The second thing is, R5 routes. I want to see if they are present in this R4. So show IP route VRF customer A.
On router 5.
On R4.
Yeah. Okay.
Those routes are not even coming the others, right? So,
Yeah, see, I'm checking, but I checked, means you told me to check these route as well, V4, and I'm getting this. See, this on router
Oh, what is R5's network? Give me R5's network.
50. This belongs, means, yeah, 50.
R5 is 50, right?
Yeah, there is also a loopback interface, /32.
Okay, so R5 network is there in the VPN v4. Okay, so
Yeah.
now go to R3 and check if that is coming to the VPN v4 on R3 side.
Okay. It is also getting, I think, DTP. VPN v4. Yeah, I'm also getting this.
50 is coming via 172.1.1.1.1.
Yeah.
Okay.
One more
Now
interesting
check-
thing actually I would like to show you here. See, this interface actually, this interface is connecting to router 8 where RIP is connected. But I'm not able to ping this.
Which interface? I think your screen is stuck.
Okay, just first let me show you. See, this is router 3 which is connecting to router 8 via this interface 1/2. Okay, and one VRF is applied to this interface.
Wait a minute. Right now, I just lost the connection to that CLI, and now I am seeing the GNS application.
Yes. I'm showing you actually the router 3 is
The
connected.
diagram, huh? Okay.
Yeah. So, serial 1/2. And the one VRF is applied to this interface. Now see what is happening. I'm not able to ping this IP address.
99 is the R8 IP, is it?
Yeah, means
99 is the R8's IP, is it?
Yeah. This 992 is a WAN IP actually.
You cannot ping with this command. You cannot ping with this command. You can only ping with ping VRF blah blah blah. I mean ping under that VRF. Only then you can ping. Right now it is looking at the global routing table, so you can't ping. Use the command ping VRF and then give the IP address. Deepak, are you there?
Yes, yes. Yeah, it's pinging. Yeah, it's pinging.
Okay. Yeah.
And even, could you please let me know the command for this show IP RIP neighbor? Is it fine? Or I have to put the VRF?
No, what I want to see is, you are seeing them as VP and V4 routes on R3. Now
Yes.
I want to see if they are coming as BGP routes into the VRF itself. So give the command show IP route VRF customer A, whatever that is.
Yeah, I'm getting these routes, means 50 belongs to my router 5 and 100.
50 is there. Okay.
Yeah, and
Now
111
go to R8. Yeah, go to R8 and see if that route is coming there or not. R8. Show IP route RIP. Yeah, control plane is right, fine, right? You
Yeah.
said that route is not coming.
No, route is coming, but I am not able to ping. See,
Okay. Okay, so in this, the control plane is coming, but that you are not able to ping. Okay, change that loop back to that other than /32.
okay.
Which route you said it's not coming? You said this R6 route is not coming, no? Which route
Yes,
is not
yes.
coming?
Means I got it. For this problem, I will change the loop back. I will create a new loop back with the means /24 so that it should work. Okay, I got it for this, but I have another problem. Means I am getting these routes on the router 4 in BGP, VP, and V4 routes, but those routes are not coming to this router 5 actually in the routing table. Router 5. See.
So here 110 and all that is not coming. So here go to R4 and show me whether you are getting it in the BGP or not.
Yeah, I'm getting actually here for this.
So our focus is on that network 111, right? 111. Okay.
Yeah, 111 and 100.
111 and 100. Where is 100?
100 is there actually on the router 8. Loop
Okay,
back.
so that 100 is also not coming from R3 to R4 itself, right?
Yes, right.
Okay, so let us focus on that 111 first of all. So on that 111, that is in the BGP, VP and V4, and just want to check route distinguisher is 6514:1. Okay, fine. Now show IP route VRF customer whatever. So I got it as a VP and V4. Is it in my VRF routing table?
Where is my shit? Just give me a moment.
As far as I am concerned, you are just scrolling up. So maybe there is some lag. I don't know. What I am hearing, you're typing something, but what I'm seeing, you're just scrolling up.
Yeah. Now you can see that we can means we are getting the routes in VRF as well. Kalyan, can you hear me?
Okay, give me a minute. Yes, I can hear you, but I'm not able to see it.
Means we are getting the route.
Now I can see
VRF as well.
IP route VRF.
Yeah, this one, and we are getting this 111 here.
Yeah. I want to see it. Okay, now I can see this route. I have the route 50 and I have the route via BGP. Okay, so I'm able to see that route. Now I can see you expanding that. I mean, selecting 111.
Yeah,
Okay.
we are getting the routes in the
So
VRRP.
now show run section EIGRP.
Yes, because through EIGRP, neighbor is connected. Yeah,
So
through
here, did I redistribute? Blah 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 blah. Okay.
So do we need autonomous system on this IP4 family? Need to
He already configured, so
okay.
this is.
yeah. And,
Would you like to check BGP?
not now. Router EIGRP 10, and then you have an address family for that. And then there is a router EIGRP 2 with another address family. Why did you run two different EIGRP parent connections?
No, for not parent connection actually. These
Parent EIGRP processors. There are two parent EIGRP processors.
EIGRP2 is for my customer B only, and EIGRP10 is.
No. That is, see, you don't run EIGRP two parent processes for two customers. Only one EIGRP process. Within that one EIGRP process, you will have two address families.
Okay.
You are supposed to have two address families, and here you redistributed 10, redistributed 2. I mean, you're trying all possibilities, right? Whatever, I will just redistribute everything.
Yeah.
Let us see it will work.
To achieve the target, I have made several changes, means 100 of 100 changes.
Okay. Yeah. One thing I want to check, okay, show IP EIGRP neighbor for that customer. I want to check whether that neighbor adjacency is actually there or not.
Adjacency is there.
So neighbor adjacency is there. And show me BGP. I hope you did not run. No, you can't even run two BGPs. But again, address family, I have to check. Okay, so show me.
Yeah, there is only a one. See.
Hold on. Customer A3, you have EIGRP 10 metric you gave, and
actually,
then you are
because
correct.
Yes, and there is a separate address family for customer B. Now I'm surprised, for customer B everything is fine, but why I'm not getting the route for this?
Because I guess EIGRP 2 is what you configured first, I guess, maybe. Okay, so again, I'll come back, and when I come back, I will log into your box and let us walk through the steps. Okay.
Previously, I would like to
So guys, come back by 2:45 and then we will continue the class. It should work. It just should work. Okay. So
Yes.
I don't know. It's a caveat, or is it is it a bug, or this is just the way your BGP should work, like in the L3 VPN ROM. The documentation is really not there.
Yes, that's why I was.
That is how it has to be. It's very weird. Yeah. Yes. It is a very weird thing. And I remember, almost a decade back, I was trying everything to communicate. Nothing is happening. And just like that, okay, whatever, I will try this. And then it worked. At that time, I was not even getting the message saying a /32, if you gave, it won't work. Nowadays, you are getting that message. Okay, so I like to believe it's a caveat actually. Okay, it's a caveat and why I should not use a 32. I mean, why I should go for anything other than 30.
All right.
But yeah, that's one of those things. You just have to give it.
Okay, no problem. Got it. But Kalyan, in my scenario, actually, for customer B, I have also configured a loopback IP address on /32, which is working fine. So I don't know GNS as caveat or what.
No, not at all GNS. I don't want to call it a GNS caveat. And remember, the issue is only when you have the router IDs. It's not about customer. It's not about any other loopback. That router ID which I use, R1, R3, for them to form adjacency, I use 1111 here, 3311 here. These have to be configured point to point. If I get the route of this as 3311/32, I don't send the data packet.
Okay. Means data plane will not work, correct?
Data plane will not work. Only for the router IDs. It's not about customer routes. Customer can give any routes they want. Decide the customer R7 or R5 or R8, they can have anything they want. But the router IDs between the PE routers, it can be loopback 1, loopback 0 can be 32. See that? Loopback 0 can be 32. But if I'm using loopback 1, which is my next hop, if that is a 32, then only it won't work. The data plane alone. Control plane, again, it will work. Weird, but that's how it is.
Yes, Kalyan, we got your point. That is what the reason why I was asking, because I was using /32 everywhere, so thought to why not to use 32?
Yeah. All right. So again, I think I would need about 20 minutes, I think, on this. And then we are done with first hop redundancy protocols. Okay, so here is the thing. So everything is there. Redundancy is there in a switching network. Redundancy is there in the WAN network. But if you don't have redundancy for the gateway, then everything goes swaying. So this is where they came up with this idea of first hop redundancy protocols. It is not a protocol, it's a category. Within that you have HSRP, VRRP, and GLBP. Okay. HSRP, VRRP being the Cisco proprietary, and VRRP is the open standard which you have. Okay. Now, how will they work? Now, here is the thing. What happens is, for your router interfaces, you would configure something like 10.2 and 10.3. These are the interface IP addresses of the gateways. However, for the systems, you will configure the gateway as 10.1. Where is 10.1? That is going to be a virtual IP address that you will configure, which is shared by both the routers, both the gateways in your environment. Okay, but how will they know each other? And how do they know that they should be configured with this VIP address? Now, this is where your configuration comes into play. What you do is you will configure these interfaces in the HSRP or a VRRP group. Now, for the most part, everything I am explaining is very similar to HSRP and VRRP. Subtle differences are there, and as I keep explaining, I will give you those differences. But for the most part, they work exactly the same. So what happens is, I configure this in a group. Now, once I configure this in a group, they will start sending their HSRP and VRRP messages to discover each other. Now, Only if they fall into the same group will they be able to form the adjacency. They will be able to know themselves. Right. So here you have again, just like any other adjacencies, you have states like listen state. In the listen state, what we do is we are going to send the multicast packets to discover the hello packets, and we will start listening to the other HSRP members. Now, once I cross the listen state, I will go into a state called the speak state. Very funny names. When I go to the speak state, this is where the election happens. One of these gateways is going to act like an active gateway, the primary, and the other one is going to act like a backup. Now, in the speak state, the decisions are taken. This is where the election process happens. Based on the priority, if the priority is the same based on the IP address of these interfaces, you're going to have one as the primary, the other one as the backup, secondary. Okay. Higher the priority, better. Lower the IP address, better. So, with regards to HSRP, the primary is called as active and the secondary is called standby. With regards to VRRP, the primary is called master and the secondary is called backup. Okay. Now, one other question. We don't need more than two, but let us say there is another router also, which you can very well have, no problems. You can have absolutely no problem, whether it is HSRP or VRRP, you can still have. But the only thing is, the other routers that come up, which are not active or standby, master or backup in VRRP, they are just in the listen state. So it's not like they are stuck there. They just keep listening to the hello packets coming. When it comes to HSRP, the timer is 3 seconds and 10 seconds is the whole time. When it comes to VRRP, 1 second and 3 seconds is the whole time. Now, by looking at it, it looks like, oh my God, HSRP will take a long time to reconverge. Yes, if you leave it to the defaults, but you can change the timers here also. So initially it may look like a big problem, but it's not. The default values are this. If you want quick convergence, you can set the values to like what VRRP has. Okay. Right. So that's one thing. So now what happens is this. Okay. Now you have this 10.1 virtual IP address, which is known to these because you configured in the same group, and in that group you configured the VIP. What happens is, once you have the VIP address and the group ID you give, automatically they will create a virtual MAC address. Now, for HSRP, VRRP, there is a reserved MAC address that they keep using. But what happens is, for example, I'm giving a random number, okay? So AC something 5A or something like that. And then what happens is, the last byte, it's a 48-bit number, right? So the last byte is going to be the group ID that is going to be added to the virtual MAC address. Okay. So now both of them are sharing a virtual IP address. Both of them are now going to have a common virtual MAC address because they have the same group ID that is added in the virtual MAC, and that becomes a common ID for both of them. And during this process, one of them decided to be the active. Okay. So fine. Let us say this is the active router. What next? This is what happens. When any system in the 10.x, if they want to communicate, they are configured as 10.1 being the gateway, which happens to be the virtual IP address. Okay. So now let us say 10.5 is trying to communicate to 10.1, the gateway, so that it can go outside. Now they have WAN connections outside, right? So they want to communicate outside. So the very first thing that they do is they send an ARP request, right? So when they send an ARP request, the switch is receiving it. Switch does not know where 10.1 is. It does not know the MAC address of it. And this is a broadcast request, by the way. So when it is a broadcast request, I'm going to send it to every port in that VLAN, of course. So I'm going to send it onto this switch, onto this port, and even onto this port. So the switches will send it everywhere, right? So both the gateways are going to receive it, the ARP request for the gateway's MAC. However, this, because it's a standby, or if it is VRRP backup, it is not going to respond. It won't respond. Rather, the active router is the one which is going to respond for the ARP request. So once it responds, switch 1 will get the unicast, ARP unicast response. So it will learn, okay, for example, I'm saying 1A, okay? So the gateway 1A is on port number 5. I will know about it. I will learn the source MAC address, right? And then I will send it to the system here. By this time, I already know 5A because I learned it on this port when the request is made. So now the switch knows that the gateway is sitting on port number 5. Okay, how about 10.7? So when 10.7 wants to communicate to the gateway, again, it will for the first time send an ARP broadcast that will go to this. The switch 2 will send it to everybody. It will be sent to this, and on this side. The switch 1, because it's a broadcast message, it will send it to everybody again. Again, the active router will respond. Only the active router is responding. So when the response comes, I already know 5. 1A is connected to port number 5. And when I send the frame on this side, because I know 7A is connected in this direction, so I send it. Now switch 2 will learn, okay, this 1A is connected to port 25, for example. And switch 2 will send the response back to 10.7. Okay. Now, all the systems like this are going to only talk to this active gateway because only the active gateway is going to respond to the ARP requests. Okay, I mean, that's simple, very easily understood. What if something goes wrong with this active router R1? So if R1 links goes down, what happens? What happens? I mean, we know it, right? What happens? The standby router will take the active role and then it will start taking the gateway request. Over. Yeah, but it's not that easy. There is a small information detail missing here. See, I want a quick convergence, right? When this link goes down, switch 1 knows about it. Switch 1 knows because the physical link went down. Immediately this entry is removed from the MAC address table because the port is down. Okay. Switch 2, however, it does not know about it. Switch 2 thinks whenever any frames are coming to this gateway MAC, I will always send them here. And this guy does not know where 1A is because the port is gone. So it will start sending it to everybody. If I have 20 switches here, I will send it to everybody. Because I can't send it back, right? Because of the basic loop problems. So I will have a miscommunication here. So if you read a documentation, this is okay, not big deal. The standby will take the role of an active, over, job done. HSRP discussion is over. No, I need to answer that. How will that switched network reconverge? Systems have to know nothing about it. They don't know, they don't have to know, because gateway is 10.1, MAC address of the gateway is 1A. They don't have to know anything new. But the switched network has to reconverge, right? So now what should happen is this. What should happen is, now all these people, all the switchers, they should know 1A as far as switch 2 is concerned. 1A is on port number 7. It should know that. Similarly, switch 1 should know 1A is no more on port 5, but it is on port number 26. It should know that. Only when it knows that, when any frames are continuously coming, see, remember, this flap happened in the gateway level. My system is already transmitting some data. All my systems are already communicating to the gateway. They should not see the disturbance. So how will the switching network reconverge? That's the one-line question. And the answer is in the details of what happens. Once this router, the standby, detects that there is a failure, depending on the hold timers, what this router R2, the standby, does is, it will send what is called as gratuitous R, GR. Okay, these are used left, right, and center in VM. Okay, whenever a virtual machine moves from one physical host to another physical host, they will also send a gratuitous R. What is gratuitous R? Nothing. Gratuitous ARP is a request made, a ARP response given without anybody making a request. It's funny, but that's what it is. So what it does is it will send broadcast of a ARP saying that, okay, I am the MAC address, I am the IP address. It just says that. Nobody is asking, but it will say, it will announce. That is what GR is. So the standby router immediately with its virtual MAC address is going to send a gratuitous R. Now what will the switches do? Always learn the new entry, right? Always they will refresh. So until this point, 25 was the port I know to reach 1A, but once the gratuitous R comes, I refresh it to 7. Because it's a broadcast, I will send it to all the switches, this side and everywhere else. So now switch 1 knows, okay, if I have to reach 1A, now the port is 26 because I received the gratuitous ARP on this side. That is how the switched environment reconverges. Small detail, but worth knowing. Okay, so this is how nothing known to the systems, your gateway is reconverging. Now, because I put a third router here, if this is gone, now this will become the active and then this becomes the standby. Okay, again, based on the priority and the IP addresses. That is how this HSRP or VRRP works.
Kalyan, I have a query.
Already I gave you, 1 minute. Already I gave you certain differences between this HSRP and VRRP with regards to the timers and with regards to the mode. And they use a different VMAC address, standard VMAC address they use, reserved. But there is one other small, tiny technical detail which is worth knowing, definitely worth knowing. And that is, when it comes to HSRP, the VIP address must be different from the physical interface IPs. But whereas when it comes to VRRP, it is okay to use one of the interface IP as VIP address. Now with this, the advantage I get is I can save one IP address. Meaning here 10.2 is there, 10.3 is there. I cannot use one of those IPs as a VIP address in HSR. But with VRRP, what I can do is I can assign 10.1 to this guy. And one of that 10.1, I can use it. So with that, I can save one IP address. Okay. I can save one IP address. Okay. I think there is a question here. Could you please explain as well here proxy ARP? RR. You mean to say RARP, right? Reverse Address Resolution Protocol? Yes, okay. Yeah. Okay. Reverse ARP or others more? I don't know. Okay. So here is the thing. I will explain you reverse ARP, RARP. I won't be able to explain you proxy ARP. I won't be able to explain you proxy ARP because proxy ARP is a little strange word. It's a very strange word. What do you mean it's a very strange word? What I mean by that is different contexts, different technologies, proxy ARP works differently. Okay. However, when we discuss OTV, we are going to discuss that, right? When we discuss OTV, we are going to talk about proxy ARP in OTV. Okay, we are going to discuss that. So right now I'm not discussing proxy ARP. Okay. And again, that's what I was telling. In OTV, proxy ARP is different. In ACI, proxy ARP is different. The word is the same, but behavior-wise, they are different behaviors. Okay. So that's why I'm not going to discuss in general because there is no one way of doing proxy ARP. And reverse ARP is like, where is it? Talk about it now. Yeah. Yes, Deepak, you want to ask something?
My query was, means in the ARP, VIP and MAC address would be same for both of routers?
Yes.
Means doesn't router 1 is having VIP and the MAC address, and if it goes down, so the router 2 will adopt the same virtual MAC address as well as IP.
Yes.
And that will be propagated to the users by GRP.
Yes.
But here confusion is that means a client is already having this gateway, and they will not face even any challenge if router 1 goes down.
Yes.
So then why router 2 is announcing this GR?
Can anybody give an answer? 1 or 2 word answer? Come on, guys. It will be really disappointing if any one of you did not answer. At least one of you, please. His question is, when the systems already know it and they don't have to reconverge, why should the standby send a GR? Come on, guys. Nobody?
First question is not able to understand.
Yeah, the question is, when the primary goes down, anyway, the systems don't have to reconverge because they already have the virtual IP address, they already have the virtual MAC address. So why should the standby send a GRP again?
Because MAC table is changing, right?
Very good. Thank you very much. I thought nobody understood it. That's what I was talking for the last 5 minutes. Because the switched environment is not converged. Systems have no problem. But the switched environment has to reconverge. Now switch 1 should say, okay, to go to gateway, I should go this direction. Switch 2 should say, no, I should not go into this, now I should go in this direction. Everybody has to now reconverse to this particular port, na? For that, not for the systems. Systems don't have any clue. It's not even required, but it goes because it's a broadcast. But the major reason for the GRP is the switched network to reconverge. Now my MAC address table should move to the new one, new port. Are you clear, Deepak?
Yeah, means the router 2's physical ports MAC address will also come into the picture.
No. This guy is sending 10.1 is my IP, 1A is my MAC. ARP reply, ARP response I'm giving, not 10.2. So now when the GRP comes with this source IP and the source MAC address, these switches will start learning. They will start learning the new port. Oh, previously it was 25. Now I am learning it through 7. So the source port is 7 now. For 1A.
Okay. Okay, got it.
All right. So that's it. That's about it. Right. Now, there are a few things which we can discuss further. Okay. Which is, for example, okay, for every VLAN, for every network, you have one gateway and one acting gateway. And if I have like 100 VLANs here, all the 100 gateways will be on a single device. So what I can do is I can create multiple groups, almost like a per VLAN STP. You can run per VLAN HSRP or VRRP. We call them as multiple groups. So 10.1, 10.2 is for this group 10 example. And maybe for group 20, I will have 20.2, 20.3. For the 20 group, I will make this guy the active. Maybe I'll change the priority. So this way I can again use multiple interfaces and make them work active for different groups. However, for a single group, you still have to go with only one active device. So this is one of the trade-offs you have. Okay. For a network, only one active. All right. The second thing which we can discuss is this thing called preemption. Okay. So what if you have this connection up and active? This is all good, but the WAN connection is gone. So if the WAN connection is gone, then all these devices going to this active router is useless, right? Because my WAN is gone, network is black holed, like the traffic is black holed. I'll just drop the packets. So what I should do in English, what I should do is, if this link goes down, my WAN link, if that goes down, R2 should become the active router. Okay. Now, some change happens in the middle. R1 should become standby, R2 should become active. This behavior is called preemption. If you look at the switched environment, preemption is enabled, like preemption will be there. Any new switch comes, automatically the changes will reflect. If you look at OSP of DRBDR, preemption is not there. If any new router comes with a better priority, no, your DR, that's it. I won't react. When it comes to HSRP, the same thing. Preemption is not enabled, meaning this is already active, this is standby. If you change the priority here, or maybe if you change, IP address, it will alter, but if you change the priority, for example, it won't become standby. It won't by default because preemption is not there. So what you do is you enable preemption first. By enabling preemption, what you're telling is, okay, right now priority is 150, here the priority is 100. So you are the active router. tomorrow for some reason, if I decrease the priority to 90, please change the role. You are no more active, you become standby and this will become active. So this preemption is default not enabled. You first enable it. Okay, I enabled it. So if priority decreases, accordingly, I will immediately react. Fine. So what should I do now? What's the logic? The logic is this. You will track this interface. Okay. You will track this interface, and if this interface goes down, you will configure. If this interface goes down, decrement the priority by whatever value. Okay, so in this case, if I take the same example, priority 150 and priority default 100, then what I should do is, if you track this, if this link goes down, decrement the priority by maybe 60. Anything less than 51 onwards. Because the priority here is 100, your priority should be less than 100. So that means I should subtract 51 at least. So anything less than 51, you decrement. So now what happens? Preemption is enabled. You are tracking this interface. If this link goes down now, immediately you're decrementing the value by 60, priority value, and now the priority becomes 90. Now because your priority is 90, other side priority is 100, this will become active. And now the packets will start going in this direction. And anytime the role changes, gratuitous ARP is sent for the switched environment to reconverge. Okay. So those are the couple of things. You can create multiple groups with HSRP and VRRP so that each network, each gateway will be on a separate router for load sharing, load balancing purposes. And the second is you can track WAN interfaces and you can decrement your priorities so that if something goes wrong with the WAN, you don't become the active router. That's the second thing you get. And again, if this comes back up again, whatever value you decremented will be incremented. So it will become 150 again. And then this will start acting like an active router again. Okay. Because preemption is enabled, right? That's what happens. Okay. Yeah. Any questions here?
Yes, Kalyan.
Yeah, please.
So preemption means if we have preempted this router 1 and if it goes down, so router 2 will become the active router, correct?
The WAN interface goes down. Yeah.
Yeah. Okay. And when it comes, means if router 1 goes down and it's again it comes up.
You mean to say the WAN interface goes down?
Yeah, WAN interface, or I can say total router is down somehow.
Wrong. That's why whenever you are saying router goes down, I am correcting.
Mm-hmm.
See, preemption is not enabled. Okay. Preemption is not enabled. Priority here is 150. Priority here is. Preemption is not enabled. When this link goes down, so this is currently the active gateway, this is the standby. If this link goes down, will this router become the active router? Preemption is not enabled.
Yes, router 2 will become the active.
Okay, so that's the point. Whether your preemption is enabled or not, it has nothing to do with whether once I detect that the active is down. Okay.
Mm-hmm.
The preemption is required when my active is good. This means this is up and active, no problem with this link. The only thing is priority was 150, priority is 100. Tomorrow, if I change the priority of this to 90, this will still be active. And this will still be standby. It won't change the behavior. It will still be active. it will be active as long as it is up and active. Like as long as there is no problem with that interface.
Yeah, I got your point. I got your point. It means I got your point. If something is wrong with the WAN interface, then it should reduce the priority value so that other router can come, and the router 2 can become the active router.
Right.
But I think we can achieve this without configuring preemption. But my query is, if it goes down and comes up, so it will take the again active role. It will act as a active without
this
preemption.
going down, this goes down and again comes back up.
Yeah.
That's what you're asking, right? Again, because preemption is not activated, okay, this stays as an active router as long as there is a connectivity between them, okay? Because preemption is not there. However, okay, when we saw, like when we try to do the labs and try to establish that, once active, like when it comes up, it tends to take the active role once again, whether preemption is there or not. Making sense?
Okay, Kalyan, let's say
Right.
when the primary router, let's say I am not configuring the preemption on the primary, which is currently primary, and the priority is 150. I have configured the priority only on the standby router. So when the primary goes down, automatically the standby becomes active. Correct?
Yes. There is no concept of a preemption enabled disabled. It will come active. Correct.
Yeah. So again, when the standby router, which is serving it as active, goes down, again the primary will come up.
Yes. I hope
So
that
in
is
this
up
case,
down. Okay. Don't say that is also down. This is also down. Eh?
okay, in this case, there is no need to configure preemption on the primary, which is active.
Not at all. Not at all required.
Okay.
That's why whenever Deepak was saying router goes down, I was correcting him saying, no, not router, link.
Yeah, got
If
it.
the router itself link, not even the router, if this link goes down, comes up, they will react properly. Active becomes standby becomes active, and only one will be active. That's common. I don't have anything to do with preemption.
Yeah, Kalyan. So, but I means suppose that there is a power fluctuation for router 1 for 5 minutes, 5 to 10. It means it gets reboot, or means something has wrong with this router. It gets down and come again after 10 minutes. So it was
during
active,
that time.
went
During
down.
that time, this will become the active router. Yeah.
Yes, but again after 5 minutes when router will come up, so it will take the active role again.
Yes, it will take the active role.
Okay, so what I have seen actually in lab a long back ago means it didn't take the role actually, but I had to configure the preemption. Thereafter only it takes the active role.
Yes, that is what I was telling you. When we sometimes do this labbing up and do that stuff, what we saw was when the preemption, whether it is enabled or not, okay, by rule, think logically. When you think logically, when this comes back up, again, this is supposed to be standby only, right? Because preemption is not enabled. Because preemption is not enabled, this is now the active router. What you are seeing in the lab should be the case. That is how it should be working. Okay. But again, it's been a while for me also, but what I have observed is as long as this physical link comes up, this is taking the active role. Okay. But we can lab it up and check it also tomorrow maybe. Okay. But nonetheless, this is not the key factor for me to enable preemption. This is not the key factor for me. The key factor for me to enable preemption is this link. Okay. But again, if you wanted this to be the primary for a failure scenario which you just told, okay, nothing hurts if I enable preemption for that purpose also. Okay.
But Kalyan, in the tracking system, we have option to reduce the priority. Means
That is the only option we have.
Yeah, but preemption is related to that. Or is it different?
See,
feature? Means
no. See, preemption is a mechanism. Okay. Preemption is a mechanism of, in English, what it means is react to the change. That's what it means, preemption. React to the intermediate changes. I'll repeat it myself. React immediately to the intermediate changes. That's what preemption means. Okay, how will you relate that to this decrementing value? Here is the point. If preemption, that means react to changes immediately. If I do not activate this, if this is disabled, that means don't react to the changes. If this is disabled, what is my logic saying for this tracking system? I track this. If something is wrong with this, decrement the value by 50 or 60. That means my priority will become 90. New priority once this link goes down. Now preemption is saying don't enable. That means don't react. So I won't react. Okay, you make it 90 or 9, I don't care. I won't react. This is active.
Okay.
When will I react? Only when this goes down, I will react.
Can we say means tracking will only work only when preemption is enabled? We have to
Exactly.
Oh.
We have to tell it the other way. Small difference only. If you enable preemption, then tracking will work. Same thing, but you have to tell it like this, politically speaking.
Okay, well, first we have to configure preempt the router, then tracking will work.
That's the point. Tracking will work only when preemption is enabled.
Both are associated with each other. Now,
Exactly.
what I have read so far that preemption means if router goes down, so it will come again, so it will take the active role. That's the preemption. But
yeah, that's the end result. That's the end result of it. But now you know the reason for that.
Okay. Now I got it.
Alrighty. So now with that said, and the final piece of this puzzle, this whole thing is the last thing, GLBP. Okay. I'm not sure how many people are using it, but you can have the same thing. But this time, one of the demerits of HSRP or VRRP is parallelly I cannot have multiple gateways for a single network. Yes, I can create multiple HSRP groups, but I cannot have multiple gateways parallelly operating for me. Okay. So Cisco came up with this idea of GLBP. Okay. So, so here what I'll do is logically the same stuff, meaning I'm going to configure virtual IP address. I am going to configure 10.2, 10.3, 10.4. So I will configure a common group, just like we configure with HSRP and just like we configure with VRRP. Okay. But what happens is this. One of the routers will take the role of what is called a AVG, Active Virtual Gateway, and the other routers will be taking the role of AVF, Active Virtual Forwarders. Okay. Now here is the difference between the HSRP, VRRP versus GLBP. Each of these will have a virtual MAC address given. Now, even though I'm writing like this, as if they are the physical MAC addresses, These are virtual MAC addresses derived from a reserved MAC, a group ID, and the forwarder ID. So they will get a virtual MAC address. So individually, each of them will get a virtual MAC address. Okay. Who gives them? The AVG is the one which will give. Okay. So once the AVG gives this information, what happens is when a system tries to, again, the same thing, you configure the gateway as 10.1, which is the VIP address. So what happens is when a system is making a request to the gateway, the system is going to make a request to 10.1. Okay. So when the ARP broadcast request is sent, the switch will receive it. It's a broadcast. It will be sent to everybody. When it is sent to everybody, now this gateway is going to respond with the MAC address of the first forwarder, AVF 1, AVF 2, AVF 3. So the first forwarder's MAC address, it will respond. So if you look at the ARP cache of this, you will see 10.1 mapped to 3A. So now I get the MAC address. I will make a request to this particular gateway, but the switch still does not know where 3A is. So it will send a broadcast, eventually comes to know that it is here for the second time when the frames are coming from this A. Now the switch will know that 3A is on this side. Now another system, so let's say this is 10.10. Another system is making a request to the gateway. So first thing it does is it will send an ARP. So again, when it is sent, it will be sent to everybody. Now the gateway, because it's the second ARP request, it will send the AVF2's MAC address. So if you look at this ARP cache, you will see 10.1 mapped to 4E. So now 10.11 thinks, oh, gateway is 4A, so I will send my frames to this 4A. So the switch will send it to this. Inevitably, the response comes. Now the switch will know that 4A is connected here. You're getting the catch. If another system makes a request, I will send it to the AVG. It takes the request. AVG will now give the third AVF MAC address. Now 10.13 comes into picture. When it comes into picture, it will get to the gateway. The gateway now gives its own MAC address. So meaning the AVG can also act like a forwarder. So you can have up to 4 AVF, including the AVG. You can have 4 of them. So now what is happening? Each one of the systems is going to get a different gateway MAC address. Each one of them is going to get a different gateway MAC address. So they are going to talk to those respective gateways, and therefore, parallelly, you are able to send the traffic to multiple gateways at the same time. This is what happens with GLBP. Now, here you can tweak certain configurations. By default, it is round robin. Okay, so AVF1, AVF2, AVF3, AVF itself. Again, AVF1, AVF2, AVF3, again itself. So this way it will round robin fashion, depending on the number of requests coming, I'm going to share that load. I can also set some crazy things. Like for example, I can set weight to all these AVFs. This is a relative value. For example, I set a weight of 10 here, weight of 5 here, and maybe, otherwise I'll say 8, 4, and 2. So if I set a weight of like this, then what happens? 8 requests will be, this will be the gateway. For 4 requests, this will be the gateway. For 2 requests, this will be the gateway. So it's like an unequal cost load balance. I can do that weighted round robin also, wherein depending on the weight of the AVF configured, your request will be distributed. I can do that. Okay, what if something goes wrong? Right. So if something goes wrong, it is the AVG that is going to tell It's not a GR kind of a thing. Okay, what AVG will do is, AVG will tell, depending on the weights, otherwise round robin. Okay, AVF2, if you are getting frames for 3A, you should take care of that. So because this link is down, that 3A, that AVF1 is gone. So it's a AVG that will decide, okay, AVF2, you will respond to requests coming for 3A. So once that AVG gives the information to AVF, AVF will send a credit USR for 3A. Okay, and then everybody in the switched environment will reconverge to 3A. So for a period of time, that is also something you can configure. For a period of time, this router AVF is going to respond to requests going to 4A and 3A. As far as the systems are concerned, they don't really care. Okay. So this is the overview of what GLBP can do. Parallelly, I can have multiple gateways active at a time for a single network. Okay. So I think I will draw the line here. I will draw the line here for this stuff. And tomorrow we will be discussing ether channels, and then from there I will take you towards the data center technologies. Definitely VPC. I don't think we will start fabric path. So we have 3 more days. I think VPC, VDC, FEX, these things I will cover tomorrow. Fabric path and OTV we can cover on a single day. And finally, the VXLAN stuff, we will cover that. I don't think we need a full day for the last day, but we will see. But we'll see what happens. Okay. All right. Getting this 111, 111. That's the primary thing we'll focus right now. So R4.
Routers 7, 5, and 8 belongs to customer A.
So show IP about VRF.
One more thing, I have,
and then this is.
I have configured the RD value on both 3 routers, like router 1, router 4, and router 3 for this customer.
Fine. Okay.
Is it correct?
Yeah. For the same customer, right?
Yeah, for the same customer, RD is same on both routers. Oh, sorry, on 3 routers.
And only back is that. Yeah, then. Just curious. Okay. R4 has it in its BGP table, but you are not seeing that in the EIGRP side of it. So run section GP.
Can we reset the neighborship between router 4 and router 5? Will that work? I'm not sure.
Talking from practical experience. Huh? The first step is restart. The second step is restart. Third step is do the first 2 steps. Right. The troubleshooting steps we follow, right? That is the last resort. Wait a minute. Customer.
Actually, I don't believe
Okay.
in sometimes. Got it?
BGP. Okay, I want to check here.
What I was saying, I'm saying that I don't believe GMS actually. Sometimes routers gets hanged. So Kalyan, is my BGP configuration fine? Means BGP
looks fine.
perspective?
Yeah.
Okay.
System is 10. Okay. And one 111 is here. And bandwidth. Liability.
Kalyan, if I have used the RD different for the same customer, so will it impact anyhow?
RD will not impact as long as the import exports are correct. No problems with that.
Okay.
What is the BGP number you have?
BGP 6514. BGP 6514.
Liability. Okay. Out. Yeah, got it. That's it.
So
Okay.
Due to EIGRP neighborship or
not an EIGRP neighborship per se. You don't run two EIGRP processes. Okay. And I haven't done that at all because there's no reason to do that. But I actually thought, it was okay, frankly. I thought it should be okay, even if I'm running multiple R4. Even if I'm running multiple EIGRPs, I thought it should be okay. Okay, but then I had my own doubts. You don't run two multiple processes. You don't need to run, you don't have to run. It is one EIGRP process. And within that EIGRP process, you are going to have multiple address families for multiple customers. Okay, but it happened, I am definitely guaranteeing my guess. You probably started doing this first, and then later you configured this, I think. Correct me if I'm wrong.
Yes, yeah. Yes.
So what it did was it took the only first process. So anything happening, it is only happening here. It is not taking effect of whatever is here. Okay, so that's the problem. You really don't need it. And at this point, I have learned that you should not even have it. That's what I learned at this point.
So could you please try to ping that IP, means 111 on the router 5?
No, from router 5.
Yeah, from the router 5, means whether it is pinging or.
So ping 111.111.1.10.
Okay. That I can correct by configuring the loopback IP address as /24.
Okay. Yeah.
Do it. And one more thing, only. Could you please go to the router 6 for customer B and can check, means still we are getting all routes or not on the router?
Yeah, sure.
Because it's fine actually. It's reachable up to router 10. So yeah, adjacent IP route. See, now what is happening? Now I'm getting routes on the customer A, but not getting routes for customers.
Customer B.
Yeah.
Okay.
It is all happening due to EIGRP.
Sorry. Here I did not do that. Nah. So router EIGRP 1234. Come on. Router EIGRP 1234. And to show IPVR. Here I did not do the reverse redistribution, right? So that was family. I already configured that, right? So, redistribute VTP. What is that number? I'm sorry.
6514. 6514.
Metric bandwidth, reliability, load, and empty. Okay, so to show IP. Now on R6. Yeah, that's it. Okay. I cannot do that reverse. Okay.
Now I'm getting. Okay.
All right, guys.
Thank you so much for this.
Yeah.